So section 2.4 is all about, whoops, wrong color. 2.4 is all about complex numbers. We're going to learn about complex numbers. We're going to talk about how to do basic math. We're going back to the basics with our new kind of number. Okay? So let's talk about this new number. You thought you knew about numbers. You thought you knew. But you knew baby numbers. You knew about, like, the basic numbers, right? So we have this category. Last time we talked on Monday, we talked about these different categories of numbers. And two broad categories we have are the group of numbers we call real numbers. Real numbers. Right? And that was things like we had the counting numbers. Counting numbers. That was like 1, 2, 3, whoa. 2, 3, 55, 97, etc. Your basic type of numbers, your counting numbers. We also had integer numbers. Integers. Integers are all the negatives. -5, -4, -3, and 0, and also 1, 2, up to, like, keep going with those. So all the negatives and all the positives, we had those integer numbers. Integers. Integers were all the negatives, including all the countings, right? So we're talking about, like, bigger and bigger groups. Beyond the integer numbers, we had what we called rational numbers. Right? The numbers between the numbers, like 2/3 or 0.651. Any decimal that will end or repeat forever, 0.11111 forever, which is the same thing as 1/9. So repeating decimals and ending decimals are rational numbers. 0.11111. Another group we had that was separate from all of these other ones were irrational numbers. Irrational. And that was things like pi and e, and also includes things like the square root of 2 or the square root of 5. Those are irrational numbers. That, remember, these never repeat, well, I should say they're decimals. Decimals that never repeat and never end. Special category, irrational numbers. So we had real numbers, all these different categories, like the basic numbers we talked about. And then someone mentioned we also have imaginary numbers. Imaginary numbers are that I, which is the square root of -1. So you can have things like the square root of -6 is going to become root 6i. So imaginary numbers work kind of like you take the negative out of the problem, right? Take the negative out, and it becomes an imaginary. Or if you have, like, the square root of -9, that's going to become 3i, right? The square root of 9 is 3, and the negative square root becomes the I. So whenever you have this negative part here, a negative in a square root, it becomes this I. A negative sign in a square root becomes an I. Negative square root becomes I. So we talked about complex, rational and irrational numbers, real numbers and imaginary numbers, as these two categories, right? A real and imaginary numbers, two different categories. What we discussed on Monday, and what we're going to talk about more today, is we're going to combine these two groups into one big number. You take a real number plus an imaginary number, and that equals a complex number. Complex number is something written like A plus B I. It has a real part, which is the A, and it has an imaginary part, which is the B that's next to the I. And so you can have things like 6 minus 3i. I don't know if you all can hear my cat. She's having a real bad time. I'm too busy for petting her. Yes, I'm sorry, Mango. No pets for you. All right, 6 plus 3i, 6 minus 3i, for example, is a complex number. This, what looks like an equation, is one single number. 6 minus 3i is one number. It's one like location, right? And we have our real part, which is 6. So like A is 6. And we have our B part, our imaginary part here. The B is equal to negative 3. Right? Because B is only the B number. The I is there automatically. The I just tells us it's the imaginary part. But the B number is just negative 3. B is just negative 3. Right? The real part is 6. The imaginary part is negative 3. Okay? So real numbers, complex numbers. Every number that we use have been complex numbers. Every number we talk about in this section right now is going to be a complex number. So that's a complex number. Another example of a complex number is 4. This is a complex number. 4 is a complex number. Well, how is it a complex number? What's the imaginary part? Well, the real part, A, is 4. What is the B number equal to? What's the B value? What's my imaginary part? It doesn't exist. So my imaginary part of this number is 0. Right? I can say plus 0i. So the number 4 is a complex number. It just has 0 for its imaginary part. And so you can think about numbers like that. All the numbers we do, all of them are complex numbers. Sometimes they have 0 for one part or the other, but they have a real, right? Their real or their imaginary part. But they're all complex numbers. So the number 4, the real part is 4, the imaginary part is 0. So get that into your mind. Think about that. Every number is actually a complex number. And so with these numbers, we're going to think about what we can do with them. We're going to go back to the basics. I'm going to show you how do you do the basics. How do we add, subtract, multiply, and divide these complex numbers? So things we can do. Things we can do with complex numbers. What are some things we can do with these complex numbers? And the first thing we can do is let's learn how to add them together. How do I add some complex numbers? For example, if I have 2 minus 3i, right? There's a complex number, 2 minus 3i. There's one complex number. Plus 4 plus 7i, right? So there's two complex numbers. How do I fit these together? What do I do here? What we're going to do is simply combine like terms. We're going to add, oh, goodness gracious, we're going to add the pieces that are the same together. Combine like terms. So my real parts are going to combine together. Add the real parts. 2 plus 4 is going to make 6. Yeah. Add the real parts. And my imaginary parts, I'm going to add those together as well. Add the imaginary. -3. Remember, this is a negative number. -3. The -3 part. Don't forget the negative. -3 plus 7. 7, 6, 5, 4. That's going to be plus 4i. And that's your answer. All right, negative is just a regular 6. Okay? Questions about that? So in our new problem, we had 2 complex numbers, and we added these numbers together. We just add the like terms. So the real parts add together, the imaginary parts add together, and that creates a new complex number with a real part of 6 and an imaginary part of 4. Right, so my real part would be 6, and my imaginary part is 4. Okay. So, no problem. Adding, you're just combining like terms. What about subtracting? We can also subtract complex numbers. For example, if I have, let's say, -5 plus 2i minus 3 minus 9i, what's going to happen here? Right, complex number. How do I add these together? Well, with subtraction, there's sort of one extra step. What you need to do is make sure you distribute your negative, right? Distribute the negative, distribute the negative, distribute the minus sign. And so you're simplifying. The same way you do in any other situation, you're going to kind of simplify. So we're going to have -5 plus 2i minus 3 minus makes plus 9i. And then combine like terms. -5, -3, that's going to make -5, 6, 7, 8. -8 for a real part. Plus my imaginary part. I'm going to have 2i and 9i. That's going to make 11i. And that's my answer. Okay? So I can combine my like terms, add your numbers, subtract, right? Make sure you distribute the negative just like regular. Distribute that negative sign. All right, and subtracting, pretty basic. That was like 2nd grade. Yeah. Congratulations, everyone. You graduated from 2nd grade complex numbers. let's move on to like 3rd, maybe 4th grade. We're going to multiply. Multiply. How do we multiply? Multiplying complex numbers is going to require a little bit more. Like I said, it's a little bit more complex. Get it, everybody? A little bit more complex. Oh, Mr. Mitchell, you're so funny. Thank you very much. I appreciate that. So 4th grade, everyone, let's learn how to multiply the complex numbers. So we're going to do, for example, we're going to do, let's see, what's a good one? 3 minus 2i times 4 plus, we'll just leave I by itself. 4 plus I by itself. 3 minus 2i times 4 plus I. Multiply these complex numbers together. When you're multiplying, well, look what we have. We have 2 parentheses, right, next to each other. We know how to multiply this. We've done this before. We're going to do some distribution. We're going to distribute. Distribute, distribute, goodness gracious. Distribute, aka foiling. So we're going to take the 3, multiply it by both the 4 and the I. So we're going to get 3 times 4 is 12. 3 times I is plus 3i. Okay? Same with the -2. Distribute that to both the pieces here. Distribute and FOIL. So we're going to multiply -2i times 4. -2 times 4 is -8i. Yeah. And then -2i times, remember this is a 1 here. There's a, whoa, that's too big. There's a 1 in front of the I here. There's an invisible 1. So -2i times 1i. Anyone want to guess what that makes? -2i times 1i. What is that going to make? Yes, Alfredo squared. -2i squared. Yes, these are good. -2i squared. And so now we have this like I squared piece that's a little bit different. So you're going to need to memorize, I'm going to write over here, the powers of I. Powers of I. And you're going to have to memorize this list. Or at least understand where they come from. Because you can take I to various exponents, and you're going to need to like simplify. So let's look just like I by itself. I by itself is just the square root of -1. So I by itself is just I. If you have I squared, well, that means you have the square root of -1. Square root of -1 squared. And what is that going to become? Square root of -1 squared. If you square a square root, the square root and the square cancel, you're left with -1. So I squared makes -1. I squared turns into -1. So we're going to change this I squared. We're going to like cross it out and say it's really a -1. I squared is really a negative 1. So I've got 12. I'm going to combine these two together, 3i minus 8i, those combine together to make negative 5i. And then I've got negative 2 times negative 1. These two multiply to make plus 2. So now I've got the 12 and the plus 2, so really I'm going to combine those together, 12 and 2. Those two make 14 minus 5i, and this is my answer. (14 plus 5i). So your answer will only have one real part and one I part. I don't want to see in your answer, you don't want to have any I squareds, you don't want to have any I cubes, anything else. It's just a real part and an imaginary part, only those two pieces. Your final answer should only have the imaginary part, the real part, those two pieces. So when you have an I squared, realize that I squared becomes negative 1. Okay. But when we multiply, sometimes we get bigger exponents too. We can have an I to the 3rd power, I to the 4th power, I to the 10th power. How do we deal with different powers of I? Well, I'm going to show you here. So I is I squared is negative 1. I cubed, if we have an I to the 3rd power, well, that's just like saying I squared times I. I cubed, right? I cubed is like an I squared piece and a regular I piece together. So I squared times I, right? There's a 2 and a 1. We have 3. 2 i's times 1 more I makes 3 i's. I cubed is I squared times I. I squared, we know what I squared is. I squared is negative 1. I squared is negative 1. And I is just I. So this is going to become negative I. So I cubed changes to negative I is just I squared is negative 1. I cubed is negative I. What about I to the 4th power? Anyone want to follow this pattern, see what they think? What about I to the 4th power? What do you think I to the 4th power is going to make, everybody? What kind of thing would I to the 4th power make? Well, it's 2 I squares. Yes, it's like I squared, but it's not 2 times I squared. It's an I squared times another I squared times another I squared. And that's not the same as 2I squared, because 2I squared is I squared plus I squared. So we don't have that, right? We don't have 2I squared. We're not adding. It's I squared times another I squared. So if we have I squared times I squared, what happens when these two multiply? What number is that going to make? Negative 2, not negative 2. What's I squared equal to? Well, I squared was negative 1. So I have a negative 1 times another negative 1. Alfredo got it. It's going to equal 1. Plain old 1, because we have a negative 1 times a negative 1. And that goes back to, yeah, equals 1. Let's keep going. I to the 5th power, everybody. Who's got a guess? What's out of the 5th power? Think about the patterns here. I to the 5th power. What do you think that's going to be? You could do, yeah, you could do I squared times I cubed for sure. Multiply these two together, I squared times I cubed. What's that going to make? If it's I squared times I cubed, I squared times I cubed, what's that going to make? I squared is -1. I cubed is negative I. -1 times negative I, what's that going to make? Yeah, perfect. Back to regular I, everybody. I to the 5th power, another way you could see it is I to the 4th times I, and I to the 4th is just 1 times I, so we have I. Either way, we get back to I. And so here's the trick about powers of I. Here's the trick. Once you get past the power of 4, you repeat back to the beginning, and your exponents repeat. So I to the 6th power is the same thing as I to the 2nd power, which is -1. Your pattern is going to repeat. After the 4th power, everything after 4 repeats back to I. So 5th is I, 6, 7, 8. 9 back to I, 10, 11, 12. 13 back to I, 14, 15, 16. Right? You keep repeating this pattern of these 4 over and over again. So these are the ones you need to memorize. These powers of I are the ones you need to have memorized, because that pattern just repeats over and over again. I to the 6th power will be the same as I to the 2nd power, which will be -1, right? The pattern just repeats itself. I to the 7th is going to be the same as, oh God, this pen is just, sorry everybody, my messiness. I to the 7th power, Jeebus. I to the 7th power is going to be the same as I to the 3rd power, which is going to be -I. I to the 8th power is going to be the same as I to the 4th power, which is going to be 1. And you keep repeating your patterns over and over again. I, -1, -I, 1. I, -1, -I, 1. Over and over again. Okay? Useful when you multiply. So, here's a question I have. What is I to the power of 53? Yeah, I'll write this bottom one again. I to the 8th power is I to the 4th power is back to 1. That's I to the 6th power. All right, I to the 53rd power. What do we think? Kermit thinks it's -I. How do we tell? What's I to the 53rd? Which of these 4, which of our pattern is I to the 53rd power going to be equal to? Where does it fall in our pattern? I to the 53rd power. Well, I want to know, is it the same as I cubed, same as I to the 4th, same as I squared? Here's an easy way to tell. To figure it out, divide 53, God, hold on. Divide 53 divided by 4 and find the remainder. You want to know how many cycles did 53 go through? How many cycles of 4 did 53 go through? How many times does 4 go into 53, everybody? (53 divided by 4), that's going to be 1. It's going to be 13 times with the remainder of 1, right? Right, 4 into 53, if you imagine. 1 time, that's a 4. minus, minus, that gets a 1. Drop the 3, that's 3 times with a 12. So that's going to be minus those, you get remainder of 1. That remainder is the same thing as what you get. So it's going to be I. That remainder is the exponent that you have. That remainder is the equivalent exponent. It's going to be I to the first power. It goes in 13 times the remainder of 1. So it cycles through 13 times, and then it has one more number that it goes through. So that remainder is the equivalent exponent. That's how you can figure it out. This situation is called a modulus operator. Not important, but if you get some crazy exponent, divide it by 4, find the remainder, and that remainder is where you fit in the category. Remainder of 0 is the same thing as I to the 0 power, which is just 1. So if it goes in evenly, you know it's like the fourth one. All right, everybody. Little bit of a hint and trip. You won't hopefully need this too much, but if you do get a crazy I, divide it by 4, see where it falls in the cycle. All right, everybody? How much time we got? 20 minutes. Great. So we got to multiplying. One more thing about multiplying I need to show you all. Can I move away from here? I'm going to move over here. One more thing about multiplication. I'm going to give you another example for multiplication. Let's multiply 2 plus 5i times 2 minus 5i. Plus 5i times 2 minus 5i. So I'm going to multiply these two together. Same thing, I'm going to need to distribute. So 2 times 2, that's going to be 4. 2 times minus 5i is minus 10i. 5 times 2 is plus 10i. And 5 times 5 is minus 25i squared. These two numbers multiply together. We're going to simplify. I know that I squared is negative 1, so I'm going to cancel this I squared and make it into a negative 1. So I'm going to get 4, and then I have this minus 10i plus 10i. Well, if I combine those, they're going to cancel out. These two are going to cancel out. My I part is going to disappear. The negative 10i plus the 10i goes away. And then I have negative 25 times negative 1. That's going to be plus 25. So my answer is going to be 29. And that's it. This is a special kind of situation with multiplication. A special situation. This is called a conjugate pair. Conjugate pair. And we've talked about these before. Right? When we're talking about simplifying or things like that. A conjugate pair means they're the same numbers. Same numbers. One is a plus and 1 is a minus. A conjugate pair is any situation where you have these two multiplications where one has a plus sign One has a plus sign, and one has a minus sign. They're both a 2 and a 5. One is 2 plus 5, one is 2 minus 5. And that's a conjugate pair. It's an important feature or type of multiplication that you do. And there's a really easy trick for these conjugate pairs. The trick for the conjugate pairs is the middle. No, not write that there. Let me write this over somewhere else. The trick for the conjugate pairs, right up here, is take the first number, the 2, right? Square the first number, right? 2 times 2 is going to be 4. Yeah? Take the last number, square the last number, 5. And that's going to be, where am I going to go? 25. So it's, and then add those numbers together, and that'll be your trick. And that's how you find a conjugate pair. Really simple. First number square it, last number square it, add them together. That's how you do. If you notice something is a conjugate pair, a really fast way to do that answer is take the first number square it, last number square it, because you know the middle is going to cancel. Conjugate pairs, the middle will always cancel. So tricks for that conjugate pair: square the first number, square the last number, add those two numbers together. So for example, everybody, if we had another one, 3 minus 7i times 3 plus 7i, what's the answer for this one? First, is this a conjugate pair? Are they the same number with a plus and a minus? 3 minus 7 and 3 plus 7, yeah, they look like the same. Both the same. Yeah, conjugate pair. What's going to be my answer? Well, I take the first number, 3, square it. That's going to be 9. Squared is 9. 3 squared becomes 9. 7 squared. 7 squared is what? 7 times 7, and remember there's perfect squares. 49, thank you. So 49 plus 9, that's going to be, what is that, 58? There's your answer. Real fast way to do conjugate pairs. This is going to be important in our last step. Knowing how to do conjugate pairs, all right? So you've got your, so we graduated first grade, second grade, we know how to add, subtract. Fourth grade, third grade, fourth grade, we know how to multiply. We're going to get to fifth grade, everybody. Man, you're just like burning through these grades. Adding, subtracting, multiplying, dividing. Just like skipping grades here and there. Let's talk about dividing. How do we divide? Not driving, dividing. How do we divide complex numbers? So with dividing, you have something like, let's say we have the complex number, let's do 4 plus I, 4 plus I, the top number, divided by, I'm going to write it like a fraction, divided by 2 minus 3i. 4 plus I divided by 2 minus 3I. How do I do this? With dividing, every division problem of a complex number involves a little trick. And the trick is we never want I, we do not want I on the bottom of fractions. On the bottom of fractions. No I's on the bottom. Hey. I's up here, everybody. Huh? I's up here. No I's on the bottom. I's up here, everybody. Only on the top. So, no I's on the bottom. So we have to fix this. We have to get rid of this I on the denominator. Cancel the I on the denominator. We are going to do that is we're going to multiply the top and the bottom by the conjugate. 2 plus 3I. And that is going to cancel that I on the denominator. Multiply by the conjugate. Okay, no I's on the denominator. So, let's figure this out. Multiply by the conjugate. So that means on the bottom, I know how to do the bottom part real simple, right? I do my little trick. I square my 2, I square my 3, and I add them together. So that's going to be 4 plus 9. Easy, right? Use the trick. On the top part, I need to do a little bit more distribution, right? I need to actually multiply these two things together. I have to distribute. My pen is working now. Fantastic. So 4 times 2, that's going to be 8. 4 times 3, that's going to be plus 12I. I times 2, that's going to be plus 2I. And then I times 3 is going to be plus 3I squared. So I do the multiplication on the top, regular foiling, distributing on the top. Bottom, I can use my conjugate trick because I know that's where I get the conjugate from. It's always the conjugate of the denominator. Always the conjugate of the bottom one. Conjugate of denominator. It's always the bottom, right? No I's on the bottom, I's up here. So cancel the bottom part, use your denominator. So let's simplify this. I know that 4 plus 9, that's going to be 13 in the denominator. I squared, I know that's going to be negative 1. So I'm going to have, let's see, 8, this is negative 13. 8 minus 13 is going to be negative 5. 12 plus 2I is plus 14I. And there's my answer. Okay. Negative 5 plus 14 on the top. Where did the 13 come from? 13 came from 4 plus 9, right? I did my conjugate on the denominator. Right, I did the conjugate, which means I square the first number, the 2. Oh. Did I write 13? Oh, thank you. No, you're right. Sorry, that should be negative 3. Negative 3. I saw 13, I don't know why. 8 minus 3, that's going to be positive. Oopsies, positive 5. Thank you. Good catch. Positive 5. 5 plus 14I. That's my answer there. So this is my answer, but I need to take one more step. This is not our final. This is not even my final form. Not even here. Okay. We need to do one more step here to really finish it up. Because remember, a complex number has a real part plus an imaginary part. So we're going to finish this by splitting this. Goodness gracious. Split. We have to split this. Split into a plus bi. So I'm going to take the 5 and make it separate and put that over 13. Plus, I'm going to take the 14i over 13. And this is my final answer. Each of the pieces get a 13. The 13 goes to either one. 13 goes to both. Right? I like share it. 5 over 13 plus 14i over 13. Each one gets the 13, and we split it into the real part and the imaginary part, right? So now we have our real part. The real part of the answer is 5 over 13, and the imaginary part of the answer is 14 over 13. So we see we can like split it into pieces now. And you need to take this last step before you get to your final form. This is the final form that we're looking for. Okay? Okay. My goodness. 13. There. All right, everybody? So you are 5th grade, learning how to divide. Dividing your complex numbers involves taking the conjugate, multiply by the conjugate, multiply by the conjugate of the denominator. Use the trick. Use the trick where you square both sides, and then split it into a plus bi. Simplify your top, right? Do your distribution on the top. Those steps. Should we try one more? Divide. 6 over 7 minus I. Take a minute right now. Try this one on your own. I'm going to check in 30 seconds. Take 1 minute, try that out. Try this question on your own. When you're done, let me know in the chat. Let me know in the chat when you're done. All right, we got it, folks? Let's do this together. See how well your answers work. So first thing I'm going to do, when we have this process, first thing we do is multiply by the denominator conjugate. So the conjugate of 7 minus I is going to be 7 plus I. So multiply the top and the bottom by 7 plus I. That's step number 1. Then on the denominator, I do my little trick. I square the first number, I square the last number. So 7 squared is 49. I squared, what number is in front of here, everybody? What number is in front of the I? Yeah, that's a 1. So that's going to be plus 1 on the denominator. 49 plus 1. On the top, I have to just do the regular multiplication. This time it's only a 6, so I just distribute that answer to both. 6 times 7, what is that? 42 plus 6I. That's a 1, everybody. So the answer for this one, 42 plus 6I over 50. And when I split my answer, I get a 42 over 50 plus a 6I over 50. Very good. Am I done with this problem? Kind of. I can go a little further. Again, this is not even my final form. I can reduce, simplify, and I will always want you to simplify to the lowest possible number. I can divide both by 2, the 42 and the 50, right? This can become 25, this can become 21. Right? 6 and 50, I can reduce that to 25, and that's a 3. So really, my final answer should be 21 over 25 plus 3I over 25. And this is my final answer there. Okay? All the little bits. So make sure you are simplifying your final answer as well. Sometimes you need to reduce it, and that'll be okay. All right, everybody? So we have 1 minute left. Let me just do one more quick little intro. What if I have, for example, something like, let's put it all together. What if I have something like, let's see, what's a good one? The square root of negative 8 times the square root of negative 4. How do I do this? How do I do this problem? In problems like this, when you have a negative square root, you have to convert to I. So square root of 8 is going to be square root of 8I. Square root of 4, oh goodness, it's not really a good I. Square root of 8 times I, right? The negative number goes out of the square root, becomes an I. Square root of 4, that's going to become 2I. Square root of 4, right? Becomes square root of negative 1 times square root of 4. Square root of negative 1 is I. Square root of 4 is 2, so 2i. Multiply now these two together. You're going to get 2 root 8 I squared. I squared is negative 1, so it's negative 2 root 8. So sometimes you will have some questions where you'll have to do some converting to I. Just one quick last little thing about when you see square roots of negatives, make sure you turn those into i's. All right, everybody. Your homework is on Schoology. Schoology. Check it out there. Homework on Schoology. I will see you all on Friday when this homework is due. We'll go over stuff. That's it for me, everyone. Thank you. Type goodbye in the chat. Once you type goodbye, you're free to go. Well done today. I will see you all next time. Thank you very much.